Hello everyone. Today I'm going to present our work GlocalNet, class-aware long-term human motion synthesis. My name is Neeraj Vatan and currently I'm pursuing my master's at CVIT IIIT Hyderabad under the supervision of Dr. Avinash Sharma on 3D human motion analysis. Human motion synthesis is the task of predicting 3D human joint locations for a specified time interval. 3D human motion synthesis is an interesting problem due to the rise of several data-driven applications aimed at the generation of synthetic human motion. There are several challenges involved in this task, such as long-term temporal dependencies among poses, cyclic repetition across poses, variable speed of actions, and partially overlapping human activities. Human motion synthesis has several applications such as 3D character animations, pedestrian trajectory prediction, and medical field applications. 3D character animations are used in video games and animated movies. Pedestrian trajectory prediction can be used to predict the future location of pedestrian and avoid any accident. Human motion synthesis can be used to check the efficacy of surgery before it is performed. Our major contributions are as follows. We propose a novel two-stage deep learning method to synthesize long-term human motion. Our method is capable of generating class-aware motion trajectories. And finally, proposed method can generate a new motion trajectory as a temporal sequence of multiple activity types. We propose a two-stage generation model where the first stage, GlocalNet, deals with learning the global pose dependencies in activity sequences by learning to synthesize a sparse motion trajectory. And the second stage, GlocalGen, addresses the generation of dense motion trajectories, taking the output of the first stage as input. The first stage takes as input a sequence of sparse set of t initial poses and generates the next t poses. The architecture of GlocalGen consists of a sequence-to-sequence autoencoder, but we provide all the encodings of encoder, unlike a normal sequence-to-sequence autoencoder. The second stage takes the interpolated poses as input and outputs the smooth dense poses. We use the same architecture for this stage as well. To check the efficacy of our method, we perform several experiments such as generation of sequence of actions, generation of different activities based on input labels starting with same initial frames, and plotting the TSNE embeddings of GlocalGen encoder's output. Using the same set of sparse initial poses, our method can generate different type of activities based on the input class label. The figure depicts two such activities, drinking and standing up, that were synthesized from the same set of initial poses. Our method is also capable of transitioning across actions. The figure demonstrates the transition from standing up to drinking activity. This is the TSNE plot of GlocalGen embedding subspace, along with the plot of selected motion trajectories, where multiple samples for different classes are represented as color-coded 3D points. Following are the limitations of our work that we are going to work on in future. Rotation and translation are not considered while generating the human motion. There are limits to control on pace of the generated FPS. Following are the takeaways and conclusion of our work. We propose a novel two-stage method for synthesizing long-term human motion trajectories. The proposed method can also generate new motion trajectories as a sequence of multiple activities. Our method allows us to control the pace of generated activities as well. Thank you. And please let me know in case you have any questions.